Greetings, HISD community and math scholars. My name is Mr. Jones and I am coming to you currently a 7th grade middle school math teacher here in Houston ISD. And today I want to share a lesson with you about generating ratios. Not only are we generating ratios, but we're generating ratios fluently. That means you can do it in your sleep. The objective for today, you ask, I will learn how to generate equivalent ratios fluently. The vocabulary that you need to know is per, proportion, rate, ratios, and scale factor. Again, that's per, proportion, rate, ratios, and scale factor. Okay? So per means for each. Another word for per that mathematicians also use is every and for one. For every and for one. Those are other words that are used interchangeably for per. So for example, you may hear a nutritionist say 280 calories per serving, or a clerk at a gas station say that they charge $1.29 per gallon. A proportion is an equation which defines that the two given ratios are equivalent to each other. Example, 2/5 is equivalent to 6/15. And all we're doing is multiplying 3 times the numerator and the denominator in order to get the equivalent proportion. A rate is a comparison by division of two quantities measured in different units. Okay, so a common rate that you may see on a daily basis is 60 miles per hour. Always notice the speed limit on the way to school. It's usually somewhere around 60 miles per hour, unless you're in the school zone. So miles per hour is the rate, the comparison of two different units. Ratio, a multiplicative comparison of two quantities expressed with the same units. People often compare boys to girls, maybe in the classroom or different clubs and organizations, or just in the crowd in general, boys to girls. And although they're different, the unit of measure is the same, which is people. Scale factor is the ratio between corresponding measurements of an object and a representation of that object. So in 6th and 7th grade, you may see scale drawing comparing two different shapes to see if they're proportional. And you have a scale factor, and the scale factor for scaling up is a ratio greater than 1, and a scale factor for scaling down is a ratio less than 1. Let's get started, and we're going to start with the do now. That's right, do it now. You can do it. Mr. Jones is so busy putting in grades for his class that he forgot to feed 3 of his dogs. Only 1 of his dogs is already eaten, okay? So what is the ratio of hungry dogs to the dogs that have already eaten? Can you believe it, Mr. Jones? He hears those dogs. Mr. Jones, you got to do better than that. There are 3 ways to communicate and express ratios, right? So the first way is the fraction form. The second way is you write a colon with the little 2 dots in the middle. And the third way is to write it in word form, right? So you're going to write it just as you say it, 3, 2, 1. And you always read it out 3, 2, 1. So even if you see the colon or if you see the fraction, you're still going to say the word 2. So 3, 2, 1, 3, 2, 1, 3, 2, 1. You just see it differently. It just looks different. Ready for our first activity? I thought so. So this is pretty much the easy activity. All it is counting the school supplies, right? And yeah, it's the middle of the school year and we already know what those look like. So all we have to do is identify them, count them, and write the amount. One of the school supplies that they asked for first are the pencils, okay? And let's see, I'm gonna give you about 30 seconds to identify what the pencils look like, because I had a little trouble differentiating the pencils from the colored pencils. Yep, you're right. Those are the pencils. There are 3 pencils, guys. 3 pencils. Good job. I told you this was going to be easy. All it is identify, counting, writing the amount. The erasers. How many erasers? All mathematicians know that the way to be the best mathematician is to make sure you keep an eraser, because you're going to make a lot of mistakes. So I know you guys out there know where the erasers are. Yes, there are 4 erasers, 4 total erasers. Okay, so I'm going to put 4 right there underneath the erasers. Now, guys, I want you to identify the markers, the colored pencils, and the crayons on your own. I'm setting the timer for 30 seconds, starting now. There's 5 markers, there's 5 colored pencils, and there's 3 crayons. Given the total of school supplies to be 20, right? So we got an even number. I love even numbers. So we have 20. Now the next task is to make ratios comparing the 2 different school supplies, or 2 forms of school supplies, right? So the first box, you have pencils to colored pencils. And using our guide to the left, I'd like for you guys to complete this activity, putting the appropriate ratios in the boxes. I'll give you 30 seconds. All right, so time's up. Let's see if you guys have solved this entire activity. See if you guys have identified the items and counted the amount and wrote it down underneath the school supply. All right, so for pencils to color pencils, I got 3 to 5. There's 3 pencils to 5 colored pencils. Markers to erasers, there's a total of 5 markers and 4 erasers. So I put 5:4, right? But you read it 5-4, okay? Don't forget that. Crayons to school supplies. So there's a total of 3 crayons and there's a total of 20 school supplies. So I wrote 3 to 20. Erasers to pencils. There's a total of 4 erasers and there's a total of 3 pencils. Okay? 4 to 3. Aha, they tried to trick me. They put writing utensils to school supplies because those erasers that there are 4 of, we don't write with those. So only the markers, the pencils, the colored pencils, and the crayons as well. Total up to be 16, and the total school supplies will be 20. So I put 16 to 20. Colored pencils to markers. There's 5 colored pencils and there's 5 markers. Okay, so I put 5 to 5. And also, guys, you could have written this in word form. You also could have written this in fraction form. I just chose a colon because it was easier for me to write in those little bitty boxes. Crayons to erasers. There are a total of 3 crayons and 4 erasers. So therefore I put 3:4. But I read it 3:4. All right. Markers to pencils. There are a total of 5 markers and 3 pencils. So I wrote 5 to 3. And there you have it. We both solved this together. You guys are brilliant. I couldn't do it without you. A painter from House Paint Inc. mixed 6 gallons of blue paint with every 10 gallon of yellow paint in order to make a green paint. Which ratio of gallons of blue paint to gallons of yellow paint will make the same shade of green paint? Let's think for a second. So I see my 6 gallons of blue paint and I see my 10 gallons of yellow paint, okay? And they say that is the perfect combination of blue and yellow paint in order to make green paint. So it's very important that I get these ratios correct, or else I'm gonna come out with some lime green paint or some pale green. I want the perfect green. You know, like that forest green paint. Yeah. All right. So let's start. Okay, so the first order of business is I'm gonna first write my ratio, okay? And my ratio in the word problem is 6/10. Now I told you earlier that the easiest way to solve a ratio or to see if something is proportional to a ratio is to make sure that you write it in a fraction form. Be sure to write the fraction just as you see it in the problem. So if I see 6 blue gallons first, I'm going to write 6 blue gallons over the 10 yellow gallons of paint, all right? So if I saw yellow first, I will write yellow on top, okay? So make sure that the order, it's organized appropriately, because that's very, very key to solving these problems. So I have 6 blue over 10 yellow. Let's look at the first answer choice. So the first answer choice says 7 to 11. And I think I know what they did. They just basically added 1 to 6 and added 1 to 10 to make 7 to 11. But everyone knows that in order to see what's proportional with a ratio, you can't add nor can you subtract. So 6 plus 1 equals 7, 10 plus 1 equals 11. You got to try harder than that to get me. Okay, so now let's look at B, the ratio 30 to 18. Remember, we have to write the ratio in the very order it was presented. So if I were to multiply the numerator by 5, I would get 30. However, when I multiply that same 5 times 10, the denominator, I get 50 and not 18. So the answer can't be B. Remember, in order for 30 to 18 to be correct, it must be proportional with 6 to 10. Let's look at answer choice C, 20 to 12. I'm going to follow the same strategy as I did with answer choice B. Again, I will write 20 to 12 in fraction form and see if it's proportional with 6 to 10. I see that 6 doesn't go into 20 evenly, and the same for 10 into 12. When this happens, I use my world-renowned cross multiplication strategy to see if the two ratios are proportional. So I see that when I cross multiply 12 times 6, I get 72. And when I cross multiply 10 times 20, I get 200. In order for this strategy to work, both of these products must be the same. So C isn't correct either. Now for D, using the same strategy, I place the ratio side by side, 6 over 10 and 24 over 40, to check and see if they're proportional. I see that I can multiply 6 times 4 to get 24 and 10 times 4 to get 40. So this would be the correct answer, scholars, because the 6 to 10 ratio of blue to yellow paint is proportional with the 24 to 40 ratio of blue to yellow paint. See, now you've got it. Let's keep it going while we're on the roll. 2 fountain drinks with different capacities are shown below. Which correctly compares the capacities of the 2 fountain drinks? Well, let's take a look at A. The large drink holds 1 ounce for every 3 ounces of small drink. Well, if I look at the number 8, I can't break that down into groups of 3. And even if I did, I would get 2 groups of 3, and then I would have a remainder. So no, that's not correct. Let's look at B. The large drink holds 2/3 times as much as the small drink. So I know I have to multiply 2/3 times 8 over 1. And when I do so, I get 16 over 3, which gives me a mixed number 5 1/3. So that wouldn't be correct. So C says the large drink holds 4 times as much as the small drink. Well, I know 8 plus 4 is 12, but the answer choice says 4 times 8. So 4 times 8, that gives me 32. Nah. D says the large drink holds 1.5 times as much as the small drink. So I look at the small drink and I see 8 over 1 times 3 over 2. Now 3 over 2 is how I make 1.5 into an improper fraction. So 1.5 is equivalent to 3 over 2. And I multiply 8 over 1 times 3 over 2, and I get 24 over 2, giving me the answer of 12. So yes, D is the correct answer. Okay, let's do a quick check for understanding. So the ratio of green M&Ms to yellow is 2 to 5. So let me ask you this. What actually came first? The green or the yellow? Correct, the green. So the number 2 represents green and 5 represents yellow. Remember when I said earlier that the order is extremely important. If there are only green and yellow M&Ms in the bag, what is the smallest number of M&Ms possible? Well, I know the ratio of green M&Ms to yellow is 2 to 5. So what if there were only 2 green M&Ms in the bag and there were 5 yellow M&Ms in the bag? Then that would make the smallest number 7. There would be 7 total M&Ms in the bag. Just a reminder of the order. So it's very imperative that you get the order correct. The ratio of green M&Ms to yellow is 2 to 5. If there are 84 M&Ms in the bag altogether, how many are green? Let's see, if there are 84 M&Ms. So they've given me a ratio of green to yellow M&Ms. And with the additional information, it says now that they know the total amount of M&Ms, which is 84. So I know that 84 will go on the denominator of the ratio. And so when I set up my first ratio, which is 2 over 7, then the denominator of my second ratio has to be 84. I know that 7 times 12 gives me 84. So I have to multiply the same thing by the top, which is 2 times 12, will give me 24. So if there were a total of 84 M&Ms, then the amount of green M&Ms would be 24. Shemaya is preparing to knit using 2 skeins of yarn with lengths shown below. Which comparison correctly describes the 2 skeins of yarn? A. The red yarn is 4/3 times the length of the purple yarn. B. The purple yarn is 4/3 times the length of the red yarn. C. The red yarn has 4 feet for every 3 feet of the purple yarn. And D. The purple yarn has 3 feet for every 4 feet of the red yarn. Okay. So if I look at A, I see the red yarn is 4/3 times the length of the purple yarn. And so I'm going to multiply 4/3 times the amount of the purple yarn is 12 feet, right? So it's 12 over 1 times 4/3, giving me a product of 48 over 3, which ultimately is 16 when simplified. I know my red yarn is 9 and not 16. Let's try B. The purple yarn is 4/3 times the length of the red yarn. Okay, well here goes the 4/3 fraction again. Let's see if it works this time. So I'm going to multiply 4/3 times 9. And when I do that, I get 12. So B looks correct. But let me try C and D just to make sure. So it says the red yarn has 4 feet for every 3 feet of the purple yarn. So that if with that specific ratio, it's giving the red yarn more feet than the purple yarn. And I know that's not the case. So let's skip to D. The purple yarn has 3 feet for every 4 feet of the red yarn. So D is basically C flipped backwards. It's saying the same thing. It's saying that the purple yarn has less feet and the red yarn has more feet. So my best choice is B. The purple yarn is 4/3 times the length of the red yarn. And for all you math scholars out there that work diligently along with me, I am pretty sure you guys got the answer B. Okay. The ratio of men to women living in downtown Houston is 3-1. What could be a possible equivalent ratio of men to women living in downtown Houston? Could the answer be 500 to 200, 100 to 300, 600 to 200, or 350 to 150? How about I give you 30 seconds? Good job, guys. The answer would be C, 600 to 200. And the reason being is when you write 3-1 in fraction form, you're actually multiplying both the numerator and the denominator by 200. And so you would get 600 to 200. Alright guys, now that we have completed the lesson for today, I'd like to give you guys a quick lesson summary. I have learned how to generate ratios fluently. And here's a couple of tips to remember. The 3 ways to write ratios are in a fraction form, using a colon, and word form. And always remember to say the word to, no matter how the ratio is written. So if the ratio reads 3/4, you always say 3/4. And the last tip to remember is to be sure to write the ratio in fraction form and multiply or divide to get an equivalent ratio. And never ever add or subtract. Hey guys, don't forget to follow me on Twitter, Mr. Jones_WMS, and on Instagram, Mr. Jones_the Great. And feel free to ask any pressing questions that you may have from the lesson. All right, guys, thank you for tuning in. Again, my name is Mr. Jones, and I thank you guys for helping me with problems generating equivalent ratios fluently. I couldn't have done it without you. I thank you so much, and make sure you tune in next week. Goodbye.